A very warm welcome to all of you to day two of the first Apollo International webinar on antimicrobial stewardship. We are delighted to have participants joining us from across India and around the world. Ladies and gentlemen, it's my pleasure to introduce Dr. Rohini Sridhar, Chief of Medical Services, Apollo Hospitals Group. With over 3 decades at Apollo, Dr. Rohini has been at the forefront of elevating care standards across the largest healthcare group in the country. She completed her medical training at AIIMS, New Delhi, and later trained in hematology in Melbourne, Australia. She brings a rare blend of clinical depth and visionary leadership. Her contributions have shaped some of Apollo's most impactful programs, from establishing bone marrow transplant services at Apollo Cancer Hospitals to spearhead the national COVID-19 vaccination rollout, coordinating seamlessly with multiple stakeholders during one of the most challenging periods in global healthcare. Dr. Rohini continues to set benchmarks in patient safety, clinical governance, and strategic excellence across the Apollo Hospital Group. Please join me in welcoming Dr. Rohini Sridhar to deliver the welcome address. Good evening, ma'am.
Yeah, thank you, Chinnu. As we celebrate World Antimicrobial Awareness Week, it is only appropriate that we gather together to also discuss, collaborate, and learn from each other on one of the topics which actually will determine the future of healthcare, will determine our ability to effectively and efficiently deal with patients in the years to come. So it's my great privilege and honor to welcome each one of you today to the first annual international webinar on best practices in antimicrobial stewardship, which is being organized by the Apollo National Antimicrobial Stewardship Program. This is not an audience to whom we need to emphasize the importance of antimicrobial stewardship, but it is a forum in which we can discuss which are the best practices which will enable us to reach our goals of rational use of antibiotics. More than ever, it is important that each one of us comes together, bringing to this difficult challenge all the skills and knowledge and experience we possess, of being able to utilize all available tools, whether it is better use of AI, whether it is better models that allow us to understand AMR, also to use all the technology that is at our disposal to overcome this extremely difficult problem. Unfortunately, this is not just a problem that can be solved with tech. It needs a lot of influence, persuasion, and convincing, because we need to move medical practice in the right direction across a country, across a community, and across wherever antibiotics are prescribed in the world. And therefore, it is imperative that we are deeply conscious of our responsibility. Every time we write a prescription, we have an opportunity not just to heal, but also to ensure that at no point are you compromising the efficacy of antibiotics. And that is at the crux of what we are trying to do with antimicrobial resistance. The magnitude of the challenge may vary, but the impact, unfortunately, will remain dismal across the world. As individual practicing clinicians, as nursing professionals, as pharmacists, as microbiologists, all of us need to come together, put our minds and hearts together with a single purpose, driven by this intent and this powerful mission to make sure that we will do whatever is in our power to ensure that antibiotics will be used only appropriately and in the most safe and effective manner. So we have a plethora of international and national faculty who will bring to this session today their knowledge, expertise, and experience. These are individuals who walked down that path of looking at antimicrobial resistance in the face and coming up with solutions and with possible options to act in each of their spheres of influence. So once again, it gives me great pleasure to invite you all to this session And I hope that you will leave this program having something that you can take back and put into practice in each of your hospitals and every healthcare delivery service where you are currently practicing. With these few words, I'd like to welcome you once again and hand it over to Chinu to take the program ahead. Thank you.
Thank you, ma'am. Thank you for your guidance. The scientific session will commence shortly. Thank you. We are pleased to invite Dr. Dhanya, Senior Pediatric Infectious Disease Consultant at Apollo Hospitals, Navi, Mumbai. She also serves as National Coordinator of the Apollo Antimicrobial Stewardship Program to commence the scientific session. We invite you, ma'am. Thank you.
Thank you, Dr. Chenu. We start the scientific session. We all know that the rising AMR and the drying antibiotic pipeline has made it essential for us to search for and develop alternative forms of treatment for multi-drug resistant infections besides antibiotics. To speak on such alternative form of treatment, it is my great privilege to invite Dr. Shauna McCollin from Switzerland. She would be speaking to us about the role of bacteriophages in the fight against superbugs. Dr. Shauna is a group leader of the phage therapy and research group within the Department of Neurourology at the Balchrist University Hospital at University of Zurich in Switzerland. Her research focuses on innovation and clinical translation in the field of phage therapy, and she has been instrumental in setting up experimental use programs on bacteriophages in Switzerland. I welcome you, Dr. Shauna. Thank you so much for agreeing to participate. Over to Dr. Shauna.
Thank you, Dr. Danya. It's really great to be here, and I really appreciate the invitation. Now, let me just get my screen up here a second, and then we can get started. All right. Are you able to see my slides? Okay.
Yes.
Okay. Well then, thank you very much again for the introduction. And I'm really excited to hear that there was an interest in phage therapy, and so that I was able to come here and speak about our work and sort of the progress that's been made in the field with bacteriophage therapy as an alternative to antibiotics. And just to get started, I wanted to show you a little bit about where our hospital is and to sort of set the preface of how we also work with phage therapy. So as mentioned, I work at the Balchrist University Hospital, which is part of the University of Zurich. You'll have the pleasure of hearing from Professor Adrian Egli later, also from the same institution. And University of Zurich is a really great ecosystem. So we have our hospital here. And then just behind it, we have our research buildings where we have our research group. And normally, I mean, my background is microbiology. And one important aspect of phage therapy is the close relationship between clinician and microbiologist. So here I have our lead clinician, who's a urologist, Dr. Lawrence Leitner, and myself, who then lead the group of phage therapy and research together in order to have this combined clinician and microbiologist duo. And so now to talk more about bacteriophages and what they have to offer in terms of the AMR crisis. Bacteriophages, I like to say that they're a multifaceted solution for a multifaceted problem. So there's some things that I want to start off with, just discussing a little bit about the background of phages, what they are and how they have been used before going into the evidence we currently have about phage therapy and their use in human medicine. And then just to end on an outlook of what I hope will be the next steps. So if we talk a little bit about just why we're all here, I'm sure you have heard a lot today about antimicrobial resistance. And it is just the fact that I wanted to emphasize is that the most recent reports will say about 1.27 million deaths worldwide. And of course, when we look in Europe, this number shrinks down to about 25,000 in Europe. And then we get to only 300 in Switzerland, which is paling in comparison to, I'm sure, the burden of AMR that you're dealing with in India. However, when we extrapolate this still is a high burden on our population and on our economy. And this amounts to over 7,000 disability adjusted life years just in Switzerland. And so now, due to this resistance and more resistant bacteria, even we're looking for alternatives and how to deal with this problem. The issue is then, of course, that we have fewer antimicrobials in drug development. So this has been dwindling since the 1980s, with fewer antibiotics becoming in the pipeline. The cost for developing new antimicrobials and conducting clinical trials is astronomical. And then we're dealing with the downstream factor of having issues with market sustainability. This is a drug that was marketed or approved, I think it was 2017 or 2019, and the company went bankrupt 1 year later due to the fact that they were not able to be sustainable through sales of their newly approved antibiotic. However, there is, of course, hope, obviously. I mean, we still need new drugs. And so I have to say that the WHO is playing a really important role in this and making sure that the information is being communicated and we have an idea of where we're going with antimicrobial development. So they recently released their 2025 analysis of new antibacterials in preclinical and clinical development. And here you have a list of the different ones that are there. And I wanted to specifically highlight non-traditionals and a category on its own of bacteriophages and phage-derived enzymes. So out of the new 19 newly approved antibacterials since 2017, these included both traditional antibiotics and some non-traditional therapies. However, none were phage-based because we currently do not have any authorized medicines on a wide scale that are phage-based. However, in this report, there are 12 phage-based products that are currently in clinical development. So that leads me then to say a short word about what bacteriophages actually are and what is their mechanism of action. So bacteriophages are naturally occurring viruses of bacteria. You can find them in a variety of different wastewater and environmental sources, as well as isolating them from human samples. And they follow a lytic life cycle where they recognize their host bacterium by receptors from their tail fibers onto the surface. And then they initiate a viral lytic life cycle where they take over the host bacterial cells to replicate and create progeny phage before the life cycle ends in bacterial lysis. And then they go on to start another cycle of infection with other bacteria. So this is the way that they act quite differently compared to antibiotics. We'll hear a little bit more about that in a few slides. But in general, this is their mechanism of action. Now, they are highly species specific. So very similar to antibiotic susceptibility testing, we also perform phage susceptibility testing. Here you can see just an example of a petri dish with a bacterial overlay and then decreasing dilutions of bacteriophage solutions. And we're looking to see the strength of the lysis and then the quantity of the bacteriophages we can count on that bacterial strain. And we like to think of bacteriophages as a new therapy, but in fact, it predates the discovery of antibiotics. So the first patient treatment was recorded as early as 1919. This was a pediatric shigellosis patient in France who was treated by Félix Derel. And then from that time point on, they were used internationally in a variety of different clinical indications. They were approved and they are approved as a therapy in countries of the former Soviet Union. And you can see here that there is an institute of bacteriophages. This is the George Eliava Institute of Bacteriophages, Microbiology and Virology in Tbilisi in Georgia, where they still conduct research into bacteriophages and create bacteriophage products that are then sold in pharmacies without a prescription. However, due to the discovery of antibiotics and just how well that they worked initially and that they still can, the use of bacteriophages was discontinued in most of the world. And this is largely due to antibiotics, but also because of inconsistent performance in early clinical trials. If you're interested in sort of seeing an overview of the different trials that have been done. There's a really good systematic review that exists in the Lancet, and so I would direct you there. So when we think of drug development, then it's sort of this linear pipeline of having ideas and basic research before entering clinical trials with phase 1, 2, and 3 trials, with the goal of reaching regulatory approval to reach patients and be sustainable. However, we'll see shortly that this is not necessarily the case with phage therapy, due both to its history and how it's being applied to today. But I think it's important with the audience of antibiotic susceptibility and our stewardship to mention a very big difference between phages and antibiotics, because they're really not the same thing. And this is because I always like to explain antibiotics as sort of a nuclear bomb when you're trying to treat a bacterial infection, compared to phage therapy, which is more like a sniper rifle. And so when we look at describing these differences, there's so many. I mean, in terms of the specificity, phages have a very, very narrow, so a species or even strain level specificity to their host pathogen. Then the localization, because phages are so much larger than a standard small molecule, that they have to really be put at the site of infection. Due to their self-amplifying nature, then this really doesn't apply to standard pharmacokinetic models. So it's very different when you deal with a self-amplifying therapy. Then resistance is also a topic that often comes up. Hopefully we will be able to discuss that, but resistance does occur to phages, but it's not always a bad thing. And then diversity. There's a huge untapped diversity of phage therapy there that even in the case of resistance, we normally would have another phage that would be able to counteract that resistance. And then also the safety. Phages, despite there being no approved products, they have been extensively used in human medicine, and therefore have a rather long track record of safe use in humans. And because we're here specifically to talk about multi-drug resistance, I wanted to touch on how phages interact with multi-drug resistant strains. So if you look here, this is just an NDM strain, AR-Bang005. This comes out of the CDC in the US, and you can see it is resistant to essentially everything. And so despite all of these different antibiotics not being effective against the strain, it's colistin and tigecycline that are still active. This is a phage test against a specific strain with one phage in dilutions, and it still is completely active. And this is mostly because there's less crossover between the pathways that phages and antibiotics will use. So just because a strain is multi-drug resistant, it has little implication for how phages will act against that strain. And then going a couple of steps further with that idea is that we can also do treatments in combination with antibiotics. And so this then often demonstrates either added activity or even synergistic activity with antibiotics. And I think I had mentioned about the development of phage resistance, and this can occur, but sometimes this is positive because it can either result in decreased virulence to the bacterial strain, or it can also lead to reversion to antibiotic susceptibility. So I know for a specific case, there's a Pseudomonas phage that then targets an efflux pump involved with resistance to antibiotics. And then if the bacteria becomes resistant, the efflux pump is no longer able to pump out antibiotics. So there's a real cross-play then between using phage resistance as a way to prolong antibiotic utility. And then, as I said, phage therapy is actually quite used a lot, despite there being no approved therapies. So we have either individual patient treatments or randomized clinical trials, and I'd like to take some time to touch on both. So when we think of them as a medicine, when we look at individual patient use, the goal here is to treat individual patients, and this is usually due to medical need, so that the patient is currently experiencing treatment failure with conventional and approved treatments. However, when we look at the cases together, they're highly variable. They have different phages, they have different protocols, and often they are poorly documented. So you know this more about from speaking with colleagues than there are in published literature. However, their widespread use in a very vulnerable population then also does help to support the safety. Now, there's no clear regulatory framework for this, except that there are countries that are now either making temporary measures or longer-term measures to allow this to happen for certain patients. So, for example, in Belgium and Portugal, they have authorized phage products as magistral preparations. And so this is then able to happen on a more regular basis for patients. Here's another good publication to look more specifically at this. So there is Queen Astrid's military hospital has now tracked 100 consecutive cases they've been involved in treating. And so they have an overview of how that's been working for their patients. And then when we switch to clinical trials, which obviously the goal here is then to create high quality evidence and make products available to patients. And there has been a number of multiple phase 1 studies that have been done in different indications that demonstrate safety. However, to date, phase 2 trials have been failing. So we will go and look through why this might be then. And I think one of the limitations why we see so much individual patient use compared to clinical trials is due to the cost of production. So you can produce phages under GMP, so good manufacturing practices, which is what is required in most countries to conduct clinical trials. But the problem is it's quite expensive, and then to invest so early in the clinical stages is often not feasible for the number of cases that are needed to be treated. So when we are involved with individual treatments, so of course this always starts with the patient at the center, that then has a clinician who agrees to take the responsibility for using phage therapy and gets the strains to a microbiologist, who then identifies and produces active phages that are then sent for quality control to make sure that they would be safe for human application. And then the patient has to undergo informed consent, that they understand the risks and benefits associated with an unproven therapy. And then they undergo treatment, during which we collect samples in order to evaluate and monitor the therapy over time. And then eventually, at some point, the goal is to share the knowledge with the community. So, for example, we treated 3 patients for recurrent UTI in, I think it was June of 2023, and I will be happy if the publication then is out by the end of this year. So there's usually a lag time between making the treatments and then having them be publicly available. But the reason these treatments are so important is for this reason, because sometimes the outcomes are really miraculous almost, where this is a very famous example that I use to demonstrate sort of the excitement or the motivation to try to use phage therapy. So this is the Tom Patterson case of a 68-year-old male who developed necrotizing pancreatitis while on holiday in Egypt. This was with multi-drug resistant Acinetobacter baumannii. And then after being transported back to the US, then he was hospitalized and fell into a coma. So this is then after the FDA approved an emergency investigational drug application for him. Then he received phage therapy into the peritoneal cavity and then IV. So this was 2 days then after he received phage therapy, he woke up from his coma. And then shortly thereafter, he was discharged. And now this is a photo of him and his wife, who have been very active in going around to sort of spread their experience with phage therapy and help to support getting these treatments for other patients who need it now. they've gone on to write a book, which is what I often give my family members for Christmas, so they know what I work on. And this has also been published several years ago. And so that's one case, but when you hear something like this really does create an excitement around phage therapy that then motivates other people to try it, or for patients to become, some patients to look for it. And if we look on a higher throughput scale, the magistral phage experience in Belgium, this is their 100 cases that I had mentioned earlier. So they do this for a number of different indications. Either here we have lower respiratory tract, surgical site infection, bones, a lower respiratory tract, bloodstream, and some others. And then they use, this is the amount of different species that they treated, and then the different combinations that they had. So sometimes it's either like a single infection, or if there's multiple bacterial at the same time. So they have different pathogen combinations. Then if we look at it as a whole, about almost 80% demonstrated clinical improvement. 60% demonstrated clinical eradication, but it was much more likely when it was combined with antibiotics. They had 15 adverse events out of the 100. And then they look at other things such as phage resistance, antibiotic resensitization, and reduced virulence outcomes. Then this is just to briefly mention that we have a project right now creating the first international registry for patients being treated with phage therapy to try to capture that value. And so individual treatments are very important because they're how to address patient needs now. And there's a growing need for this, and it gives patients a potential treatment option. But it isn't sustainable, and it's highly inequitable because it's very much in relation to resources and where you're located. So it's up to the treating physician in hospital. It is very resource intensive to treat these patients, and highly biased because there's no required reporting on the outcomes. And most importantly, it doesn't support a marketing authorization, which is what is needed. So when we go back to this image of drug development for phages, you sort of have the compassionate use that bypasses clinical trials, as does magistral preparations, as well as in existing approvals in Georgia and Russia. But then this contrasts starkly with the fact that we've seen a lot of failed phase 2 trials looking at phage efficacy. And I can see I need to not take too much longer now, so I will go through these quickly. But there are 4 completed phase 2 trials for phage therapy. I think there is now another one, but the data isn't publicly available. This is looking at chronic otitis, acute pediatric diarrhea, burn wound infections, and urinary tract infections. Now, the first one was, this was from 2009, was deemed a success, but it was never continued to phase 3. And the rest of the trials were all, for different reasons, deemed failures. They never achieved their primary endpoint. So here, I just want to say that although that they never did, they didn't approve or reach their primary endpoint, they were really important in the development of phage therapy, just to bring phage therapy into Western medicine again. There was trials done in children and demonstrating industrial interest in phage therapy. Then there was progress in manufacturing and multi-site trials. And most importantly, none showed safety concerns. However, there was always problems with patient recruitment. So it's very difficult to have a sufficient patient population for these trials. The one trial that was successful didn't progress to phase 3. And each trial seems to have very important learning lessons, but isn't advancing the field in terms of efficacy. And this, is difficult to understand when we see such positive outcomes with the individual patient treatments. Hope, of course, is not all lost. There's a lot going on right now with clinical trials. So here again is this WHO report where they list the different ongoing trials for phage-based products. And there's multiple ones already in phase 2, so hopefully we'll have some more data. There was a funding call several months ago to fund phage clinical trials, and the more attention that's being brought to phage therapy through the media and also through international organizations is helping to bring this to the next level. So to summarize, phages really can help patients, and I think there's an opportunity to prolong antibiotic utility if you can combine phages with antibiotics. However, we are at a stage where we really need more clinical trials in order to have products become more readily available as a tool. And there's the infrastructure that needs to be further elaborated in terms of investment and reimbursement, regulatory, and especially here with this audience with stewardship. And with that, I'd like to thank you for your attention. I work with a lot of great people in my team and surrounding with really, really nice projects. So I hope you enjoyed hearing about phage therapy, and if there is time or interesting questions, I would be happy to answer those.
Online হবে না? Thank you, Dr. Shauna. In interest of time, I'll ask you one question. Can you mute ID, please? Can you mute the person who's talking?
Yes. Dania, now you're muted.
How do you see the roadmap ahead from an experimental treatment to a standard care, especially in resource-rich versus resource-limited, with the background that it is the resource-limited settings where the multi-drug-resistant infection burden is high? So your comments on that?
Yes, thank you for the question. I think it's an important step to start using phage therapy is to have clinicians who are interested and to gain the experience, if that's either going to visit treatment centers where they are performing the treatments or having the firsthand experience, because it helps to develop better treatment protocols, better sample analysis, and the infrastructure with microbiology and diagnostics that is needed for these cases. So I think it is worthwhile to try in any setting to do some treatments, but then the goal should be to also work with companies who have products that are available and to try to then make this more in either a trial setting or with authorized products.
Okay, thank you, Shauna. Thank you very much. So we move on to the next session. I'll hand it over to Dr. Lena to please take it over from you. Thanks.
You are muted, Dr. Lena.
Thank you. Namaste, everyone. Myself, Dr. Lena Mendirata, Senior Consultant, Microbiology and Infection Control, Indraprasth Apollo Hospitals, New Delhi, extend a very warm welcome to all of you for our panel discussion, Advances in Microbiology for Rational Antimicrobial Practices. We are extremely honored to have with us three very distinguished experts on our panel. Dr. Camilla Rodrigues, Consultant, Microbiology and Chair, Infection Prevention and Control, Hinduja Hospital, Mumbai. Ma'am has innumerable key professional achievements to her name. Ma'am, we welcome you. Ma'am, can you kindly switch on your camera? Thank you, ma'am. We welcome you. Sir Dr. Raman Sardana, Advisor and Professor, Adjunct Clinical Microbiology and Infection Control, Indraprasth Apollo Hospitals, New Delhi. an expert contributor to national programs and guidelines. Sir is also the Secretary, Hospital Infection Society India, and also the Director, Board of Trustees at International Federation of Infection Control, IFIC UK. We welcome you, sir.
Namaste, everyone.
Professor Adrian Egley, Director, Institute of Medical Microbiology, University of Zurich. Dr. Egley is currently an adjunct foreign professor at the Karolinska Institute, Stockholm. Dr. Egley has a number of professional achievements to his name. Dr. Egley is probably just held up, but we will just start up on the session. Maybe he can join us during the course. So coming back to our panel, we as clinical microbiologists and maintaining the role of captains at the helm of the Antimicrobial Stewardship Program. So the rapid and especially the recent evolution of clinical microbiology has reinforced the importance of the role of the clinical microbiologist for rational antimicrobial practices. Starting with the pre-analytical phase. So diagnostic stewardship forms a very essential part of the antimicrobial stewardship program. One way in which clinical microbiology labs can significantly impact diagnostic accuracy and hence the quality of antimicrobial prescribing is by providing guidance in the pre-analytic phase. Dr. Camilla, ma'am, this question is towards you. Leveraging diagnostic stewardship within antimicrobial stewardship programs. What are the challenges that one faces on practical levels?
Thank you, Lena. I think diagnostic stewardship is a new word, but it's pivotal because it's the right test at the right time for the right patient. And it's kind of a continuum for antimicrobial stewardship. But there are challenges in leveraging this particular stewardship because you have to have really clear workflow integration between the lab, the clinical teams, as well as the pharmacy. And amongst this, the first is poor sample collection and transport, especially for non-sterile samples. You need to sort that out. And again, importantly, it's unnecessary or inappropriate test ordering. For example, urine culture in an asymptomatic bacteria really sometimes tends to confuse the picture. There are innumerable examples of inappropriate ordering. The second is diagnostics. We all know that enhanced lab infrastructure is so vital because over-reliance on empiric therapy, is due to the slow tact that microbiologists have been doing over the years, and it kind of impedes timely de-escalation. Rapid diagnostics are so essential, and that's the theme for this session, I know, because whether they are antigen antibody, LFAs, whether they are molecular, whether they're CRISPR, whether it's sequencing, I think they're not universally available yet. We're all making do with a little bit of this, a little bit of that. And yet, on the other hand, we need to balance overuse of expensive molecular tests. So that comes with some challenge. The third is clinician and stakeholder engagement. Education, training, and awareness. I mean, in my own hospital, sometimes I get people asking me, will you do this test? Oh, we didn't know. So you need to create an awareness. And similarly, administrative support with IT resources. And I know AI and ML is really, really going to be the future. There is a talk on that. And finally, sustainability and impact. Unless you have meaningful matrices to assess the impact of diagnostic stewardship and AMLs, they can sometimes have limited buy-in and limited expansion. Thank you.
So going on to the biomarkers, accurate biomarkers could be a boon to antimicrobial stewardship programs by providing more accurate infection diagnosis, suggesting whether bacterial, fungal, viral, monitoring the clinical responses, and guiding the duration of treatment. Dr. Camilla, ma'am, you're already on pre-analytics. So if I may ask you, the quest to find a highly sensitive and specific and readily available and interpretable biomarker. It has spanned many decades, but the perfect biomarker has yet to be found for antimicrobial stewardship. Would you tend to agree with this?
Absolutely. They can do with what's it called? They can do with CRPs, they can do the whole lot of biomarkers. So obviously when you're doing a lot, there's phlegm that you can name a list. When there's a long list, there's obviously a problem. But I think it's clinical response that really is the best biomarker. You have a patient who's sick, and when you actually start an antibiotic, you can actually see him improving, and the clinical response is eventually the best biomarker. We've come to believe over time. You can do PCT, you can look at PCT for monitoring, and to be honest, PCT really doesn't help in deciding which antibiotic you're going to do, but it certainly helps in deciding when you're going to stop, when you're going to, decrease the duration of treatment.
Right. Thank you, ma'am. So we move over to the analytical phase now. And coming to the MALDI of MS. So perhaps the most impactful technological innovation in the clinical microbiology lab over the past decade has been the introduction of the MALDI-TOF MS, the matrix assisted laser desorption ionization time flight mass spectrometry. This question is directed towards Dr. Raman Sadana, sir. As the pioneer of introducing this MALDI-TOF MS technology first into India at Apollo hospitals, how do you think this technology has impacted the antimicrobial stewardship program through the years, way back from 2012?
Thanks, Dr. Leena. Yes, I won't say it's a pioneering effect, but yes, we brought it for the first time in India for clinical usage. And Malitov obviously had a lot of potential, which it has proved over a period of time since it was introduced in 2012. And in fact, so much was the anticipation on impact that Forbes did list it as one of the three innovative things to be brought to India, techniques to be brought to India. So it was when we brought it, it was more to do with bacterial isolate and its rapid identification. And it replaced very soon, it replaced the calorimetric test of Vitek 2 compact, which we were using, and through, in fact, for bacterial isolates. And then it kept on, it's not only stood there, but it kept on updating with over time, expanded to identification of yeast, then nocardia, then mycelial fungi, and mycobacteria as well, and NTMs. So the database has been getting updated with time. We are also able to identify anaerobes within a few minutes. And I talked about certain other organisms also, like Brucella and Legionella. So it has stood very competitively on EQUAS tests and on comparatively with the conventional techniques and also molecular techniques, and the in-use devices that we were looking at, which we were using at that time. It has also, just sans a few microbes where it just errs. I think they're trying to get over that challenge also very soon. So, but it is a tremendous technique, in fact. Something which used to take about 6 to 8 hours at least is now available in 20 minutes for an individual spot, and about 1.5 hours for about 40 odd spots. So that is something which is tremendous. You can see. Not only that, it also decreased the costs of as compared to almost like we slashed down the cost of processing thoroughly. And we'll talk about it when we talk about other things. You use this MALDI-TOF now also for identification of bacteria and yeast directly from positive blood cultures when we are looking at a positive culture. Make a gram stain and go ahead with this. So it does help that way, and it has led to changing antimicrobials very appropriately, de-escalation of antibiotics, and we published a study with about 64% of our patients. We could uh, put patients on AMSP either one way or the other within 48 hours to 72 hours of receiving blood culture. So that was the impact. That is the impact that we see in our own lab.
Right, right, sir. So you did mention the costs, or anything else you may need to add on? I mean, keeping the capital cost in mind, so the use of technology, do you think it can be offset in the long run?
Yeah, in fact, I was to continue with that because I knew that something would be asked on cost. Yes, if you look at it, it was difficult, but the faith of the top management was tremendous on us, and we, eyebrows just were raised that because it was quite expensive, very expensive equipment to turn into microbiology lab. But the faith was much more than that, that what we are saying we could deliver. And yeah, it led to a lot of cost saving on time factor, on material factor, and not only for bacteria and yeast, but also for appropriate identification, as I have told about the nocardia and filamentous fungi and mycobacteria and NTMs. Obviously, Helicobacter, Campylobacter, and such type of organisms which are very difficult otherwise to identify so easily and in a quick stance. So it definitely had, and this is offset. If you look at the high cost of procurement of equipment, this in an AMSP implementation process and its benefit, time saving on labor, material, and as I have told about the accuracy of identification, it stands out as an equipment to be procured and put to good use. So, in fact, we have published many studies on how it has helped out in AMSP programs, where we have been able, patients who have been put on long-term ATT and not responding, so we could get non-diphtheria corynebacteria in them, anaerobes isolated from them. And this helped obviously towards antimicrobial stewardship with appropriate antimicrobial therapy directed towards the cause. And yes, it synergizes with conventional techniques very well. So I think overall it's a very good procurement tool.
Thank you, sir. Thank you. So moving to the next question about tuberculosis, drug resistance. The treatment has always been a therapeutic challenge because of not only the naturally high resistance level of Mycobacterium TB to antibiotics, but also the newly acquired mutations that confer further resistance. So, Dr. Kamala, considering the three main modalities for testing drug resistance in TB, the CBNAT, the line probe assay, the proportion method. So how does one method score over the other?
Yeah, thanks, Lena. Basically, I think the TB diagnostics as we know it today has really been a success story. And for the last 15 years, WHO has in an unprecedented way endorsed several modalities for testing. So if you look at the first one, the initial screening molecular test, or CBNAT, basically it's Expert MTB RIF or Expert Ultra and TrueNat, have absolutely, as you will know, been game changers. And they've really revolutionized our TB diagnostic landscape in the last decade. They are rapid, they're accurate, and they have fairly good sensitivity depending on the sample and depending on the load, ranging from about 84 to 86% with a good specificity up to almost 95%. Best part is they're as close to point of care as possible. And in our country, we are placing them at district TBs, which is a great thing. You're getting closer to the patient. LTAs actually complement the CBNATs for rapid resistance genotype profiling. In other words, they help to further look at isoniazid and rifampicin for first-line drugs, as well as look at fluoroquinolones and second-line injectables. These are deployed at IRLs because there's a certain, they're known as moderate complexity tests as per WHO. And they're deployed at IRLs in our country or culture DST labs. The sensitivity is definitely slightly less, and so we kind of restrict them to smear positives or do it directly from when we get a culture positive. And it's about 63 to 88%. But the good part is their specificity is really good and can reach from 92 to almost 100%. And the third one is rigid. I mean, I'm a microbiologist, so clearly culture is my gold standard. It is indeed, and it's a definite diagnosis for all kinds of samples. See, from a rigid culture, you can do expanded phenotypic testing for most drugs. You can detect viable bacteria. You can, it's useful for inconclusive samples. But the problem is it's really got to be done. The DST is done from culture positive, so really it's much slower. DST per se takes about from 7 to about 12 days. And we're going actually beyond that. We've started looking at universal DST from molecular methods, where we're looking at almost 17 targets, including the newer like BPAL, vidaculin, predominant, and linezolid in the form of targeted NGS, so targeted next-gen sequencing. So you have widget, which takes time, and our targeted NGS takes 3 days. So that is scoring even more than CBNAT and LIFO because it's telling us about so many other drugs. It's telling about the new and repurposed drugs. So beyond LPA, there is targeted NGS. That is the latest kid on it.
Right. Thank you, ma'am. So, so about non-tuberculous mycobacteria, ma'am, we know these are becoming increasingly prevalent now. So any comments about the drug sensitivity testing? Is it required to test in the first place? And if so, are there any available standardized methods for it?
NTM today is one of our country's failings. I'll tell you why. Because our isolation of the rapidly growing mycobacteria in all kinds of surgeries, in all kinds of, is really becoming a huge problem for us. And today, luckily, whether it's, we have a diverse manifestations of non-tuberculous mycobacteria, essentially RGM. And I think it's time that we did start doing DST, especially for the rapid growers. So the rapid growers, there is no other way but a microdilution method. Today, you're getting, standardized sensititer. It's actually basically, it's quite well done. That is important to know that you cannot do distribution. You cannot do agar dilution susceptibility testing for NT. If you look at what tests will you look at rapid growers, you look at the mainstay or the backbone of treatment for rapid growers, that is clarithromycin and amikacin. And other drugs also you look at imipenem, linezolid, tigecycline, fluoroquinolones, minocycline, etc. When you're doing phenotypic microdilution, you need to do it as per the CLSI guidelines. And the breakpoints are clearly defined there. But you need to remember that when you're looking at clarithromycin, the resistance is of two types. One is inducible and one is constitutive. The inducible resistance means you have to keep the plates for 14 days because it takes time for the gene. There's an gene that takes time to get activated in the presence of clarithromycin. You can, or azithromycin for that matter. And you need to keep the plates on for 14 days, especially for azithromycin. The rest you can read as soon as the both control comes positive. The other method, see, it takes a lot of inoculum standardization, a lot of drug stability issues like, say, independent, etc. And interpretation variability. So essential quality assurance is really vital for the phenotypic test. We started doing molecular methods, and that's available as ready-made kits today, where we look at the ARM41 gene, the C2T28 mutation, as well as we're looking at the constitutive resistance in form of the RRN. These are for the macrolides. And for amikacin, we're looking at the RRS gene, which is a 1408. They're simple formats and can be done in an LPA. Another point, just the last point, is the RGM. These are the drugs you look at. For MAC, that is Mycobacterium canceraceae, it's just rifampicin. So these are the basic drugs you need to look for across the spectrum of NTM. The other hemophilum, CIMI, malmoency, really the guidelines are not clear on that, and you really need to send it to an expert or reference.
Thank you, ma'am. Very informative that. So we move on to from TB to fungal, going on to antifungal stewardship. And we all know the COVID pandemic times especially saw increased use of antifungals. And in recent times, there seems to be an increasing trend of either in vitro resistant fungal isolates or inherently resistant fungal isolates. Ma'am, in the recent times, has there been any breakthrough in fungal sensitivity testing which could be incorporated for judicious antifungal use?
And yes, because I think it's really useful to know what is intrinsic resistance in fungi, first and foremost. For example, your clinicians need to know that QZ is intrinsically resistant to flu, Trichosporon is intrinsically resistant to Citania, Aspergillus terreus, Nidulans are intrinsically resistant to amphotericin. And similarly, Lomentospora prolificans is really becoming a problematic drug because it's resistant across several classes. So, resistance mechanisms. The tests are actually making a breakthrough because up until recently, most of us were using Vitek, which was a phenotypic panel for Candida. But remember that Vitek has clearly said only use for Candida albicans, glabrata, tropicalis, paracellosis, and I think Clusi. There's 6 of them. And people tend to use it beyond that, beyond it for other use, other Candida. We found that we're using the yeast one, a colorimetric BMD, which we found is really useful because it can be extended to most yeast. So remember that the other uncommon Candida species really do not have a breakpoint. So we report with ECB as well as Cryptococcus. We're using it for Cryptococcus in addition to those others, the 5 I described. Today, molecular PCRs are actually coming up is quite useful. We have an Aspergillus kit, which has a 28 rRNA. It's called Aspergenius. 28 RNA for species identification. Plus, it actually tells us about the TR, the tandem repeat, the TR34 and the TR36 in the CYP51A gene, and it's really fast and exciting to do. So we like this kit. We use it a lot because it tells us also about the tandem repeats. Of course, the other mutations, the the tandem repeats are in the promoter region, but the other mutations are also in CYP, which this may not be. For Candida, I think it's important to have a multiplex PCR. Try and do it in-house first, standardize it well. For the FKS mutations for echinocandins, the ERG11 for the azole resistance, especially as Candida auris is making its ugly appearance across India. So we need to remember that Canada, for Canada ORS, we need to worry about ERG11, and for FKS mutations in the other Canada, albicans, glabrata, tropicalis, etc.
Yeah, thank you, ma'am. So we move on to molecular assays, various multiplex panels, and we know now these multiplex PCR panels are commercially available for multiple specimen sources in syndromic approach, maybe CNS, upper respiratory, lower respiratory, blood, stool, joint infections. So, sir, what has been your experience with certain multiplex syndromic panels?
Yeah, we majorly used almost every multiplex syndromic panel, and we have used it in open systems and cartridge-based systems. So open platforms have been slightly challenging. They are more labor-intensive, multiple manual steps, repeated validation, and but if there are many tests simultaneously to be done, I mean, many patient samples simultaneously done, then it tends to be cost effective. Otherwise, it tends to be costly. Whereas cartridge-based tests are the much more rapid, minimal interference from human errors, and or you know, and they are quite targeted their pathogen detection, very targeted, in fact. And some of them do incorporate resistant genes and such like things. So it gives more a broader picture, especially with respect to AMSP. In fact, if we look at, we did publish an article very recently in August, I believe, I think it should have been about a few months back, August or something. So we have found that introduction of GI panel in our healthcare setup, especially it was on pediatric diarrhea. So it led to early discharge of patients from hospitals, so decreasing the A loss, and also, after controlling the acute dehydration phase, they were let off for domiciliary care, and that decreased the A loss, making beds available, as also, we also strategized into spending less resources on enforcing stringent infection prevention and control practices, because once they are discharged, then it's over. That portion is over. So we look forward to another case, and then so on and so forth. So it also, between the panel also includes pathogens which are, we will have to have multiple tests. Sometimes they will not be detected or picked up because the sensitivity of a staining procedure is quite less, and it is also dependent upon the observer, the type of person who's staining it, and such like things. So, getting a cyclospora and immediately taking a call on whether to treat with Cotramox or not, or in an immunosuppressed patient, or a cryptosporidium, so introducing netoxazonide or something very early into the treatment. So such like things have definitely brought in much relief in diagnostic stewardship. And we could institute preventive strategies and decreasing mortality and morbidity. Same thing with detecting viruses like sapoviruses. Again, and though there is a controversy on the exact usage, but still, netoxazonide has been used in certain cases with good effect. So such like things can, isolation practices and other things can be. And if it is a non-infective osmolar type of a picture coming up, and the things have been totally, so then one can relax by not giving antimicrobials. So all those things, decreasing the A loss, better utilization of healthcare resources, alleviating parents' stress, especially in pediatric age group. And obviously, there is a considerable time and material savings which come with it, and obviously other resources as well. So
Right.
that did help, yes.
Thank you, sir. So, thank you so much. I have just been told in the interest of time to quickly wind it up. So, I'm extremely thankful, grateful to both the panelists, Dr. Camilla Rodriguez, Dr. Raman Sadana, sir. Thank you so much for giving your valuable time, your valuable insight. And with that, I hand it over to Dr. Vikrant for the next session.
Can I just make one? See, when we go in for these advanced techniques,
Yes.
it is always in the best interest of diagnostic stewardship that we do carry on with conventional techniques as well, because
Right.
they are complementary rather than replacing. I think Dr. Kamila would agree with me. Culture still remains and would remain, in fact, in future too, as a mainstay. Thank you so much.
I agree, Ram. See, they're as good as the targets they're targeting. You need to remember that if they're not targeting something, you need to keep that in mind, especially for yeast, especially for the AMR determinants. So they're great when they work. And I think, to be honest, they're worth the money. And as Raman actually said, really the A loss is, we've actually done BCID studies and found that it really helped. But you need to keep in mind it's as good as the targets that are our goal.
Right.
Right.
Thank you. Thank you so much.
Thank you so much. Thank you so much, Dr. Kamila.
See you after a long time.
Thank you so much. Thank you.
Yeah, namaste everyone. I am Dr. Vikrant Khanna, Senior Manager in Office of Chief of Medical Services. And it is my privilege to introduce Dr. Sujoy Kar, Chief Medical Information Officer and Vice President of Apollo Hospitals, a distinguished clinical microbiologist whose career seamlessly blends medical science, digital innovation, and global academic leadership. With advanced training from the Indian State Institute and MIT Sloan School of Management, Dr. Kerr stands at the forefront of healthcare transformation. He co-directs the Center for Digital Health and Precision Medicine and serves as an honorary professor at University of Leicester, leads regional initiatives for the MIT Jameel Clinic, and contribute as adjunct faculty at IIM Calcutta. We welcome you, Dr. Kerr, and stage is all yours, sir.
Thank you. It is really a great pleasure to hear both Dr. Camila Rodriguez and also Dr. Raman Sardana and my colleague Lina, with whom I have worked for the past 20 years now in Apollo. And, it's very difficult to follow the footsteps of all the illustrious microbiologists like Dr. Camila Rodriguez and Dr. Raman Sardana. But I'm going to just quickly go about in next 7 minutes because I have to jump into another call in about 7 minutes. Give you a little bit of what we have been doing with some of the data that we are collecting at Apollo hospitals. And I want to talk about some of, there are ongoing research, particularly at the AMR and also use of antibiotics, multiple research that we are doing, but specifically one on the sepsis with the University of Cambridge, and the other one where we are looking at causal frameworks and diffusion models that are with my alma mater at MIT. And without doing much ado, just to give you a context of, there are over 50 projects that we are running at this hospital, at Apollo hospitals at this point of time, out of which 20 are already certified as medical device, patented, published in different, at the different journals at different point of time. And Now we have the medical device single audit program, which actually takes our solutions not only to different parts of India, but also at Australia, Brazil, Canada, Japan, and USA. And the Apollo antibiotic recommendation system, which is now integrated into your EMR, is now available for prospective use. The way we went about in making this is to take or crunch the data from 2019 till now, 20 plus locations pan India, all age group, 400,000 culture and sensitivity reports, could be more at this point of time, 57 different specimen types, 180 organisms, 141 antibiotics. So that's what we have been able to churn out in that way. We have applied for patent, and some of our papers are now ongoing with the design and prospective use under peer review. The whole objective is not very different from what we conventionally see in terms of detecting, responding, and containing resistant pathogens, but also looking at preventing spread of resistant infections through surveillance, improved antibiotic use, and then looking at what would be the different innovative forms that would provide newer insights of practice. So this is the blueprint. Of course, it's patented, but it's in a month's time, it's all going to come out in a publication. What we were doing is looking at the demographic details, the patient profile, the current empirical antibiotics, underlying conditions, concomitant medications that they're getting, and then using components of generative AI, including clinical entity recognition, relation extractions, and then going about in identifying or building, rather, at this point of time, causal frameworks to actually see the efficacy of using a particular antibiotic. So that's the whole purpose of doing this. The initial work was to now provide for a machine learning system or a recommendation system, in fact, a dual net machine learning systems, including using a Netflix-like recommendation system and then a machine learning on top of it, to give at any point of care, before you give an antibiotic, what is the possible organism that we are looking at, and historically, what are the top 3 antibiotics that are sensitive in your care setting. And when I mean in care setting, we could actually diversify this data into outpatients, inpatients, and in inpatients, particularly at ER wards, 48 hours before, 48 hours after, ICU 48 hours before, within 48 hours, and after 48 hours, and all that. And then we went on to actually look at it from a secondary data creation from the initial cohort that we were looking at, and then run what we call as the cosine similarity to actually see how some of the samples at some of the locations that we were studying, how they were behaving. And we had something which is as close as 0.99 or others, and somewhere where we would have 0.59, the diversified recommendations that would come. And classically, it was always difficult to do it with respiratory samples rather than doing it with the other samples at this point of time. And then finally, we have been able to, when we build this with the initial number of isolates and go about, we were looking at a specificity, sensitivity of 0.86, specificity of 0.87, and an accuracy of around 87%. But then the challenge for us was to then look at and go about in going the validation data and to see how this was then replicated in the different sites in different temporal perspective, and with the changing pattern of resistance that were coming in. And so far, so good. And we have been able to gather those information appropriately. The model works fine. Dr. Lina and others, including my colleague, Dr. Sanjeev, who would be talking very shortly, they had actually looked at it from the perspective also from use in patients, particularly when they have either abnormal kidney functions or liver functions, pregnancy, lactations, and that tool is now available. So anyone within the system, Apollo or outside, can actually now have a look at it and try it out in there. Of course, we will have to build it for a specific institution or for a specific city where the profiles are going to be slightly different from others. From another perspective, we have been doing the analytics to look at, the susceptibility pattern for any different, any particular, antibiotic with the different organisms that we are looking at for any different sample. And this is the core engine from which we are gathering the data to actually go about in building this. So in a nutshell, if you look at this, this is the flow. A patient comes in the outpatient clinic, look at the patient demographic data, comorbidities, current infection, medication history, antibiotics. At the time when you are giving the empirical antibiotic to this particular patient, as per your practice from a clinical perspective, you would then also go about in giving a culture and sensitivity a report. That's where when we look at what is the sample that you are sending, what are the profile of this patient, and then we are going to we are using this recommendation system and machine learning at the back end and coming out with the results. Well, so far so good again in terms of how we are doing. We are hitting an accuracy of 87%, and this is what we saw. Particularly for 82,286 culture and sensitivity report or culture sensitivity results, along with the antibiotic usage within the organization. We're hitting again slightly better than 0.59 to 0.85 in respiratory samples. In blood culture, we are pretty good in that way, blood culture and urine samples in our terms of recommendation, but again, a little bit down in terms of wound and pus samples at around 0.88. Now, for specifically the work that we are doing on blood culture, this is the work that we are doing with, at the University of Cambridge. The idea is then to go and look at the host responses along with, classical culture and sensitivity report or other biomarkers that we normally get for the infections. And typically, we would then go about and looking at, whether the Sysmex machine for full blood count, or we are looking at, from the Siemens machine, Advia machines, and identifying and plotting different cells that are and their and where they would be plotted in the graph, including again going and doing this for specifically for WBC and others. When we started this work with Cambridge and the joint labs that we work with, we had about close to about 500 data points, and typically in a report for our general use, which you see on the right hand side, you would see around 12 to 24 different data points, but we are getting about close to 500 signals to begin with, the reach data. But if you are looking at the raw data, which possibly has signals for every disease that you look at, and in that case, we are almost, there are in millions of data points that you can actually get it from a single FPC. And the idea is then to go about in looking and plotting it for healthy different viral diseases, but also look at it from bacterial diseases and see whether, and that's my specific work with a group of researchers at Cambridge, to identify if there are ways by which we are able to predict early host responses along with the antibiotic, the EARS recommendation system. If you are able to predict, the early changes, say 24 hours or 36 hours before the onset of sepsis. Early days for us, but we have got some significant amount of gains in areas like iron deficiency anemia. We're looking at in cardiovascular disease, and we're now trying to replicate the same thing in sepsis. I know it is going to be different and difficult, but that's the way that our research is actually progressing around. Blood counts publications around this are also available in net. I'm not going into the deep of this. So that's in nutshell our work at this point of time. But I think the paradigm of use of what we call as the artificial intelligence, machine learning, deep learning, generative AI on these kind of data sets and look at infectious diseases. And of course, drug resistance is boundless. So, there are a lot of people who would be doing very similar or take this approach in a different way. I'll stop there and thank you very much for inviting me. I hope to take a couple of questions if there are any, and then go about, if there are more questions around it, happy to answer through email through Dr. Dhania. Thank you.
Thank you, Dr. Sujay, for such an engaging session and learning session also for us. Any questions? I may ask one as such.
Go ahead.
So, Dr. Sujay, you have covered everything, I think, what we have opted for. So, just one question is, what role can AI play in monitoring antibiotic prescribing behavior and identifying deviation from stewardship protocols?
Well, that's an excellent question, but I think the question needs to be reframed. In many hospital systems, we are looking at very set guideline and say that you need to go about in that guideline. I think the clinical practice
Yes.
requires a little bit of liberty for the clinician to choose what is best for their patients. And I'm not saying that that means that you need to give high-end antibiotics all the time, but we need to look at it from an outcome-based causal factor to see what is it in the way that it has two outcomes in a proper way. One, about the outcome of the specific patient. B, how do you go about using the same causal structure to actually see that the antibiotic resistant patterns within your organization doesn't go up over a period of time. But again, if I have to put my microbiology head, I would rather say that is something where we will have to find a balance between the two and see how we go about in doing this.
Thank you, sir. Thank you so much. Okay, sir, one last question is just, sir, what policy or regulatory frameworks do you think are needed to accelerate the safe adoption of AI tools in AMR management?
Well, see, if you look at safety of overall from an AI perspective, there are standard ways, and at Apollo we follow a framework that we had designed, about 3 years back, and that particular thing looks at from safety, non-maleficence, accuracy, integrity, and different other stuffs that are available at this point of time, including unbiased ways of doing it. So that's exactly how you should approach in terms of design, development, and deployment of these solutions.
Thank you so much, sir. Thank you for such a marvelous session. We can move on to the next session, please. Thank you, Dr. Sujoy.
Okay. Thank you.
Thank you.
Namaste. My name is Dr. Sanjeev Sharma. We have excellent next session, role of clinical pharmacist in antimicrobial stewardship. We have a panel from around the world. Let me introduce the panel first. We have Dr. Brian Wyatt, who is from the University of Oklahoma Medical Center, he's working as a director in infectious disease department, who is basically passionate about drug dosing in obese individuals, delabeling penicillin allergy, and he's also worked in gram-positive bacteremias. My second panelist is Dr. Mohammad Isham, who is lead clinical pharmacist from Cleveland Clinic, Abu Dhabi. He is PharmD from India, board certified in critical care and infectious disease, has also worked as critical care pharmacist with publication of 30 publications and multiple invited talk with area of interest in antimicrobial stewardship and medication safety. My third panelist is Dr. Vrinda Namputri. She is basically from Amrita Institute of Medical Sciences, Faridabad, currently in Kochi campus. She has got multiple awards as emerging leader in international infectious disease from International Society for Infectious Disease, Leadership Award from Amrita Kochi. She is also acting as Vice President in the Federation of Clinical Pharmacists in India. I request my panelists to on their video. So, Dr. Vrinda, I'll just put your slides first. Let me share your slides. I'll go to your slides. Yeah. Are you able to see the slides?
Yes, yes. I hope I'm audible.
Yes, you are audible.
Can we have it on slideshow mode, please?
Is it okay now?
Yes, yes, yes. Can I go ahead?
Yeah, please.
So good evening, everyone. I hope all of you are doing well. First of all, I wish you all having a very productive WAR week at your respective hospitals. And I thank the organizers of this webinar for giving me this opportunity, Dr. Sanjeev, Dr. Danya, and the rest of the team at Apollo Hospital. So I will be very briefly discussing about the implementation of a clinical pharmacist-driven stewardship program at our hospital in Kerala. Can you move to the next slide, please? Right. So the antimicrobial stewardship was started in our hospital in 2016, and one of the major focus of the program was to have a multidisciplinary team. So the stewardship team was headed by the medical administrator, and it included physicians, intensivists, and clinical microbiologists initially. So when the program was started in our hospital, there was a lack of infectious disease trained clinical pharmacists in the state. So one of the initial interventions or initial initiatives taken by the AMS team was to train and create a role for the doctor of pharmacy students who were pursuing their course within the hospital campus. So on a rotation basis, the PharmD interns were given a chance to be trained in the antimicrobial stewardship program at our hospital. And within 6 months of AMS implementation, a full-time clinical pharmacist was appointed. Now we have a bigger team of multiple clinical pharmacists. We still do have PharmD interns who come to us for their clinical rotation. But currently, it is the role of the clinical pharmacist to actually train the PharmD interns. So the same training module is now imparted by the clinical pharmacist to the PharmD interns. Can you go to the next slide? Yes. So this is the basic workflow of the stewardship program at our hospital. This is what happens on a daily basis. So the audit and feedback intervention is what we do. And it is for the reserve antimicrobials prescribed across the hospital, across all patient population. So on a daily basis, the clinical pharmacist in our team, they collect the list of patients who are on reserve antimicrobials. They go to the patient bedside and document the patient details on a specially designed case report form. Each prescription is first evaluated by the clinical pharmacist and the PharmD interns for appropriateness, which is whether they are complying to the 5 R's, that is right indication, right drug, right dose, right frequency, and right duration. Then each prescription is then discussed with the wider AMS team, which also includes the physicians and the microbiologist. If any inappropriateness is identified in a prescription, a recommendation is passed on to the primary team of the patient. So it is communicated verbally as well as documented in the patient file. And even after a recommendation is filed, the clinical pharmacist and the team sort of follows up each of these cases until the patient gets discharged to see for compliance of AMS recommendation, follow up of any microbiology cultures, and to look for any opportunities for escalation or de-escalation of therapy. So as you can see here, the clinical pharmacists are what drives the program in our hospital, and adding these clinical pharmacists to the program actually enabled better ownership and accountability of the program as well in the hospital. Can you move to the next slide? So to quickly wrap up, these are some of our key outcomes. So within 3 years of AMS implementation, we were able to improve the appropriateness of reserve antimicrobial prescriptions in our hospital from 56% to 80%, and compliance to AMS recommendation also improved from 54 to 70%. Yes, I would like to wind up my presentation there. Thank you so much. Dr. Sanjeev, you're on mute.
My next question to you is, how do you deal with the challenges of communication with the clinicians, especially for de-escalations? What kind of challenges and how you basically overcome those challenges?
So I think not just with de-escalation, but with any AMS intervention, communication in itself is a very important skill. So as clinical pharmacists, it is very important that we learn that soft skill of how to communicate your recommendations to the clinicians. So it shouldn't come out in a way that you are trying to accuse them or you're trying to find a fault in their prescription. It should be more in a way that it's more like a co-design way where you are sharing evidence. You can provide them with some published literature, some guidelines that back up your intervention. So this is not specifically to just de-escalation, I'm saying in general as well. So I think that trust builds over time. So even when we started in 2016, we had a lot of resistance from clinicians for all the interventions that we provide. But then over time, they saw the benefit of the stewardship program, and now they are more happy to accept our recommendation. And that trust comes over time, I think.
Okay. So sometime you must have got this kind of statement. Who will be responsible if something goes wrong, right? Will you sign? Will you sign?
Yes,
Right?
absolutely. Absolutely.
Those are the real challenges.
Yes, definitely.
So what is the other challenges you find which is significant as a role of clinical pharmacists in antimicrobial stewardship you found?
So specifically for clinical pharmacists, one of the major gaps that I've noticed is the training. So we are trained in microbiology, pharmacology, therapeutics during our PharmD curriculum, but it's more a theoretical training that we receive. So when we come to a clinical practice, there is a bit of a gap there. So for us, we were very fortunate to have a bunch of clinicians in our team who actually took out time and to give us that clinical exposure and to make us understand how you need to apply those principles that you learned in your classroom to actual real world clinical scenarios. So that is one major challenge that I face with respect to clinical pharmacists. Plus, another thing is that clinical pharmacy is still evolving in India. So a lot of the pharmacists feel that there are no much opportunities here, but it is still in a very infancy stage. So there are like the PharmD program itself is just 15 years old now, 15 or 17 years old now. So it's still a new program. So there is a lot more scope to improve, but I think we need to be a little more patient and we need to take an effort to actually make yourself useful in a clinical setting.
Kerala has done quite a number of work on antimicrobial stewardship. How the country can learn from Kerala policies on antimicrobial stewardship. Can you put some light on that?
Sorry, your voice broke off in the beginning. Can you just repeat your question again?
My question is, Kerala government has done quite good
Yes.
job on antimicrobial stewardship. Can you put some light how the country can learn from Kerala government on antimicrobial stewardship?
So I think at a policy level, at a government level, there's a lot of focus on health as such in Kerala. And we some time back, we had a health secretary who was very passionate about antimicrobial resistance. And it was one of his major initiative to have a state action plan on antimicrobial resistance. So Kerala was the first state in the country to implement a state action plan immediately after the national action plan on AMR. And another thing that I find very interesting in the Kerala setting is there's a lot of public-private partnership. So for all these initiatives, there's a strong partnership between public hospitals and private hospitals. And I think that sort of a partnership and that sort of a collaboration is very important when it comes to AMR. That intersectoral, multidisciplinary collaboration, I think it's very important. Dr. Sanjeev, you're on mute again.
I welcome Dr. Muhammad Esam. Doctor, can you tell us about your work? Can you on your camera, Dr. Esam, please? Yeah, thank you so much for joining and taking time from your busy schedule. By the time I upload your slides, can you talk about your part of the world, how you are handling antimicrobial stewardship, what typically a clinical pharmacist role in antimicrobial stewardship?
Yeah, thank you, Dr. Sanjeev. I think in this part of the world, the Middle East, mostly it is still varying the role of clinical pharmacist in antimicrobial stewardship. So it could range from a hospital with very good electronic health records, where it has been leveraged to be used for optimizing stewardship, and a team of pharmacists and physicians work together, where pharmacists would have a great role in stewardship. Say a few examples I would say is like de-escalation or like drug bug mismatch, real time, where the turnaround of this is quite impactful, and a pharmacist on the first hand works with physicians to have this applied into practice. And we have institutional guidelines, national and like guidelines where which is followed accordingly. And in all of these, pharmacists play a role. It's not just optimizing, it's just to ensure there is quick turnaround and action has been taken. And it's more of because of the workforce, it's more of activating a larger group of pharmacists that may be ID trained or stewardship trained. And by having this larger group of pharmacists, you are able to reach a lot of patients. And again, when you reach most of these patients, the turnaround time, and you reach them quicker in terms of stewardship practices, in terms of like any optimization of dosing, de-escalation, drug bug mismatch, and things like that.
Thank you so much. Now, welcome, Dr. Brian. I know we are from different part of the world, and timing also maybe issue. I request you to on your camera, please.
Yeah, sorry about the mix up with the time zones.
No problem at all. Can you tell us about how you deal with how clinical pharmacists typically deal with antimicrobial stewardship part in US?
Yeah, so at OU Medical Centers, an academic medical center, we rotate between supporting 2 adult ID consult teams, 1 general and 1 transplant. And then we have a collaborative practice agreement for OPAT for patients discharged on IV antibiotics. And then we do some precepting and administrative work.
Okay.
So
how?
Oh, sure. Go ahead.
Yeah, please carry on.
Yeah. So we helped coordinate different medication access for like long-acting antibiotics or things that need prior authorizations. We have some system list in Epic for blood cultures, MRSA nasal screens, daily list of restricted antibiotics. We do some audit and feedback of anti-pseudomonal beta-lactams, and we do some penicillin allergy dose challenges and skin test.
Okay. Outpatient part, what kind of work clinical pharmacist does there?
Yeah, so mainly, patients will come in, have an invasive infection like osteomyelitis or endocarditis and need, 6 weeks of IV antibiotics. They'd get, a week or so in the hospital and then get the rest at home. And we would monitor labs on that, any kind of adverse events, any kind of PICC line complications, and sort of help manage those so people don't get readmitted.
Okay. What kind of challenges typically you face from clinicians and how you overcome that?
Yeah, I mean, audit and feedback, not everything gets accepted. We try to overcome that with system stuff, with nudges, to try to have comments and different stuff on micro. We've had some discussion about some like automatic de-escalation. I know Ashley Wild at Norton has done a lot with that, but we really haven't moved forward with that.
Okay. My next question go to Dr. Mohammad Hisham. How you deal with the clinicians in your part of the world, and what kind of challenges you face from them, and what is the strategy you follow for overcoming them?
I think stewardship, the challenges are almost same across the world if you have to deal with physicians. It's most of if you think of de-escalation or like duration of therapy or anything, you have that, okay, can I do it for one more day or can I have it for 2 more days, or like let's keep it for additional these many days. Let's discharge this is kind of which is common, but then I would say it's far better because systems in place and technologies is definitely helping, as well as diagnostics where you are able to quickly have that, and a workforce which helps a combined a team effort, and you also identify champions in the other teams, so that uh, if you identify these champions, we kind of acknowledge them, and like any communication or anything, like if say a monthly report or like a committee report where you see the top prescribers, where you have an opportunity to de-escalate and all, you have those discussions with those champions, and then they take it further to their departments or like their institutes, and from there stewardship activities also goes through that. So challenges are there, but then different ways to mitigate those are like whatever I mentioned now.
Patient is doing better. Why you want to change that? How many times you have heard this? Right? This is a real challenge.
Yes.
Okay. So my next question goes to Dr. Vrinda. Do you think that fellowship in infectious disease, especially for antimicrobial stewardship in India, will it help in clinical pharmacists here in this part of the world?
I think so, because having a very specialized training in infectious diseases would definitely try and bridge that gap between the theoretical knowledge and the practical knowledge. But I don't think that is that should be a criteria for someone to become a clinical pharmacist in stewardship. The clinical exposure, and if they have good clinical exposure and a good team backing them up and giving them that training, that is also very good. So I don't necessarily see as that as a limitation so much, but having that would definitely be added value.
Okay, thank you so much. So I want to ask Dr. Brian White, what is the pearl of wisdom you want to give the budding clinical pharmacists who want to start career in antimicrobial stewardship? What kind of advice you will give?
I think just always be learning and be humble that, everybody's here to help the patient, and people have different perspectives, and, not everything's in the medical record. There are maybe things that you don't know. So just trying to take that approach with clinicians.
Our student mode should be always on, and right, every day is a learning period. Dr. Mohammad Isam, what is your pearl of wisdom for clinical pharmacist, especially for India?
I think it's most important. Like there is a huge struggle and a gap in academia and practice. So I think overcoming that is the first hurdle. And well, again, you have to be knowledgeable enough to have those recommendations. So I would say, like, be open to learning. take that effort, extra effort to make that commitment to stewardship and optimizing those learning methods and discussing with physicians, and strong communication would also help. I think these are two things: knowledge, communication, because we obviously know there is a gap in practice because of certain systems which is not actually working in terms of bridging the gap, where clinical practice is not actually there in the academia, and those challenges could be overcome by this. And it's an effort, it's an ongoing effort, and it takes a lot of effort from the individual who would be interested. And I think that would be my words of wisdom.
Probably working in some bigger hospital where we have those systems in place and have real-time knowledge of systems and processes, how to practice this probably may help, right? My next question to Dr. Vrinda basically is what kind of 3-4 things you will suggest for clinical pharmacists in India, so that they becomes best stewards
So I
for
think,
antimicrobial stewardship.
yeah, I just want to reiterate whatever has already been discussed, like having an open mind to learning new things and being to learn it from anyone. So you can learn a lot of things from the patient, you can learn a lot of things from nurses, from all healthcare professionals for that matter. So having that open collaborative mind is very important. Soft skill development is it's very important. So understanding communication, having a focus on how to communicate your recommendation is very important. So that's an art in itself, I believe. And the third thing I would say, especially for clinical pharmacists in India, because that whole profession is just evolving here, is they need to publish more. So I do recommend that to a lot of clinical pharmacists and pharmacy students, like whatever small intervention they are doing in their hospital, make it a point to present it at conferences so that more and more people get to know the kind of work that clinical pharmacists are doing here. Also publish your work. I think these 3 things would be what I would recommend.
Okay. My next questions, Dr. Brian White. We are one of the largest democracy, and US is also oldest democracy. That's how we say. What kind of interaction we can have each other so that we do this very important role in antimicrobial resistance preventions by following antimicrobial stewardship, how we can collaborate?
Yeah, I mean, I think I would echo what the previous speaker said about getting more ideas out there. You go to a conference and you're like, man, this is a really simple thing we can do, and it had big impact. That's great. We should do it. And then from like our perspective, it's much easier to get something implemented if you're not the first person. You can be like, hey, this other hospital did it, and you can bring that to a committee meeting. I think that's very helpful. I think, surveillance as far as resistance is very important. I know, resistance is very regionally diverse, and but there's a lot of planes going between all of our locations. So
Thank you so much. I just want to ask the last one-liner from each one of you. What is the one thing you will tell? Only one-liner. One thing for a new joinee who comes to your department.
So I think for any new joinee, the one thing that I say is have an open mind to learning.
Okay. Student mode on, open mind. Dr. Hisham, what you say, the one thing to a new who comes to you the day one?
I think I still echo, like, learning is plays a huge impact. So persistently learning and continuous learning.
Okay. Thank you so much. Anything else, Dr. Brian, you want to add on this?
yeah, it's just it's a marathon. It's not a sprint. So a lot of these processes and policy changes and things take months and years, and yeah.
So be a student throughout your life. publish as much as possible, and learn from everyone, maybe a nurse, maybe a clinician, maybe a microbiologist, or patients also, and publish a lot and learn. Probably that's the way a new clinical pharmacist, and probably we can do a better job. Thank you so much, Dr. Brian White, Dr. Mohammad Isham, Dr. Vrinda, and coming and joining us at this hour. Thank you so much for your valuable time.
Thank you so much for this opportunity, and have a good evening.
Good evening. Good evening, everyone. Next, let me go to Dr. Madhukari for the next session, please. Over to you, Captain Dr. Madhukari, ma'am.
Good evening. Thanks, Dr. Sharma. Good evening, everyone. I'm Captain Madhukari Ray. I'm actually the Director of Nursing Eastern Region in Apollo Hospitals, Kolkata. I feel fortunate enough to have Dr. Enrique Castro Sazens, and who is going to talk to us about how the nursing can play a role in terms of prevention of antimicrobial resistance. And because we all know antimicrobial resistance is one of the world's most pressing public health threats, and nurses, being at the forefront and the front line of the patient care, are uniquely positioned to influence safe antibiotic use and infection control. Their vigilance directly reduces hospital-acquired infections and slows the spread of resistance microbes. And so here we have Dr. Enrique, who holds the current position as Advanced Infection Prevention and Control Clinical Specialist Nurse in and National IPC Team, UK Health Security Agency, London, UK. He has been an honorary lecturer, Health Protection Research Unit in Healthcare-Associated Infection and Antibacterial Resistance, again in London, UK. And his key professional achievements his expertise are immense in terms of global leadership in AMS learning, nursing, and he had been a contributor to national and international AMS policy and nursing workforce development. He has also shown his expertise in research on nurses' role in stewardship, developed frameworks linking nursing, behavioral science, and stewardship implementation. And his education and capacity building had been immense in terms of lecturer, integrating AMS, infection prevention, and planetary health into postgraduate curriculum in UK and Spain. Over to you, Dr. Enrique, and we are privileged to have you here for the entire session. And thanks once again.
Well, thank you so much for the opportunity to be here with you today at this point of your day. Okay, so I wonder if I can share my screen, or if someone could share my. Yeah, I can. And if you could let me know whether that's coming across. Okay. Fantastic. So
yeah, you can. Yeah, we can see, but you can put in slideshow, please.
It is in a slideshow for me,
but it is not showing in slideshow for us.
Okay. Let me try again. How about now?
Dr. Castro, if you can put the full screen option, there's this cup-like symbol on your screen on the bottom line.
Yeah, it is on mine.
It is just
you can make it full screen first, and then it will be easy for you to put it in the slideshow.
Okay, let's have a look. Apologies. Okay. What's happening now? How about now?
Yeah. Yeah, now, yeah, exactly. You can
Good now?
just click there and it will, no, click there, it is clicked. Not yet.
Let me try again. Let me try again. Sorry to everybody.
It's okay.
Is that any better?
So has become very small screen. I think if you can increase the size of the screen. Yeah, I think this is.
Still small?
Small, yeah.
No problem. You can present
I think,
in that.
I think you can continue because.
Sir, I
Okay.
think you connected dual screen, sir. Maybe you are using two monitors.
Okay, let's have a look now if you can hear me. And now I've got only one screen. And,
Yeah, it has come now.
fantastic. Okay, thank you so much for
Yeah.
that. Okay, so sorry for this delay, and thank you for the opportunity to be here with you presenting about the role that nurses can have in antimicrobial stewardship. So obviously the talk doesn't necessarily represent the opinion of my employers, and it's only my opinion. It's a great time to be talking about the contribution of nurses to antimicrobial stewardship. It's World AMR Awareness Week, and you can see that one of the key components of all the activities that we are carrying out this week, and we're meant to be carrying out every week of the year, is the involvement of healthcare workers, the contribution of healthcare workers to appropriate use of antibiotic, and that makes sense. We also have got a challenge to address that, the O'Neill report 10 years ago, more than 10 years ago already said that governments and healthcare systems really had to increase the number of essential workers who are dealing with the challenge of antimicrobial resistance. They have to be there at the front line. And that, of course, makes sense. Just to give you a bit of context, nurses are the largest healthcare workforce in the world. And you've got here data a little bit old from the World Health Organization telling you the proportion of nurses and midwives in relation to physicians. And in India in 2022, you had more than 2.3 million registered nurses and midwives in the country. And again, to give you some context, the proportion of nurses and midwives to physicians in India is around 2:1. So, more than 6 million healthcare workers, physicians, and nurses and midwives working together to address antimicrobial resistance. But of course, you can see the impact that increasing the contribution of those 2.3 million workers could be. There is no doubt by now already that good nursing care and good nursing work also means good antimicrobial stewardship. And you have got here, and I'm delighted that they were already mentioned before, you have got here some of the actions, some of the nursing work that can contribute to antimicrobial stewardship. Anything from ensuring that the administration of antimicrobials is excellent, that means not missed dose, that means administration on time, and of course through the appropriate route and in the proper dosage. Equally mentioned before, the vigilant monitoring of improvement and response of patients to antimicrobial courses is another essential nursing work. And the management of specimens, submission of microbiology culture and sensitivity samples, which of course are going to help the decision maker make that decision. And finally, again, no surprises that infection prevention and control is a key action that nurses can do. I always like to steal this sentence from this quote from my colleague Rita Olans in the US, where she said, good nursing is good antibiotic stewardship, but equally good antibiotic stewardship is good nursing. In fact, we see both as one and the same. They're not separated. And that I suppose makes sense. One of the challenges that we have, and we still have, is that it's not very clear around the world what the nursing role should be or could be towards antimicrobial stewardship. And I'll highlight some of the challenges. One of the challenges that we see around the world is that many nurses feel excluded from antimicrobial stewardship. They have got this perception that programs and systems and interventions leave them out. And you can see how many antimicrobial stewardship committees do not take into account nursing. They do not have any nurse in the panel, because the idea in many places is still that antimicrobial stewardship is all about prescribing rather than the decisions that lead to the use of antimicrobials. And that it's a historical lack of integration. So nurses don't do AMS because they feel that at no point they've been allowed or enabled or facilitated to do AMS, which is a shame, because when you actually look at what nurses do, they do perform many antimicrobial stewardship tasks. They do a lot of antimicrobial stewardship work. It's not just the administration of medicine, it's a lot of education to staff and colleagues, and of course, patients and families. There is, in many countries, nurses can prescribe, including antimicrobials, and they do it as well or as not well as any other professional. And in many countries around the world, including India, there are community health workers who are fantastic diagnosing infections such as upper respiratory tract infections, which contributes to decisions to use antibiotics. So there are many nurses and many healthcare workers around the world doing AMS, but they may not do it under the label of AMS. And I always like to show these two papers. The top one, or the top left, is a survey across many African countries asking nurses which of these jobs, which of these tasks do you do? On the bottom right, you have got a similar study in the Nordic countries. And what I find fascinating is that in both settings, there are many, many, many activities which are common. Anything from, checking microbiology results and communicating those results to the prescriber, the decision maker, developing and using national guidelines, of course, education, of course, improving decisions, taking samples, and so on. So the challenge that we've got, and that you may have in India, like we have got in many countries, and I'm from Spain, is that if we talk about antimicrobial stewardship, the nursing audience may not really know what we're talking about. But if we talk about these different activities, then it becomes a much easier and much more engaging message to the nursing audience. No one is going to convince me that all these activities here, which are all for Start Smart and Focus, are not essential nursing work. And all these actions are very useful to remember, because when we go around the world telling health systems that nurses need to be more involved, sometimes managers and ministers say, well, we don't have enough nurses, they're already really busy, and you're asking us to tell them to do something more. And our message, our response to that is that all these activities are not something more because they should be happening already. And we know they are happening already. And they contribute to optimal antimicrobial stewardship programs. Equally, when nurses don't do nursing care in an excellent way, then antimicrobial stewardship programs suffer. And you have got here a study from colleagues in South Africa exploring how there is a substantial amount of antibiotic left in the intravenous giving set, which means the patient hasn't received the full dose and is also not the dose as prescribed. And it may be that we have to improve the education about the process of administering antibiotics. Equally, in the recently published about 4 or 5 days ago, the National SPOW report, the report about antimicrobial stewardship and infections in the UK, you can see that a very striking little graph is about the percentage of blood culture samples that do not meet the minimum fill level. So that blood sample is taken, it doesn't have enough blood, the lab cannot process the sample, and therefore we cannot progress the decision about the diagnosis to that patient. This is time wasted, this is money wasted, this is care wasted for our patients. And this is an essential nursing task in the health systems where nurses take blood, which are many around the world. It may be that nurses are not that good in relation to antimicrobial stewardship because for many years we haven't had any education. And it is a bit scary to see this paper from 10 years ago where we approach all universities in the UK teaching medicine, nursing, pharmacy, veterinary medicine, and dentistry. So all the health and animal health professions who use antibiotics. And you can see the second from the right discipline, the nursing discipline, the lapses in education already at the graduate level. And in this decade, we have been really active developing competencies and developing education so nurses can have more knowledge about what they are meant to be doing. Another massive barrier for the advance of nursing in this area is that many leaders, middle leaders and institutional leaders do not really see AMS as something that nurses should do, and therefore they don't support interventions to progress the field in this area. And this is something that we really have to address because unless there is senior nursing recognition about AMS as nursing work, then there's not going to be increased interest. And also, unless we are able to develop indicators for the performance of nurses in AMS, we're not going to be able to measure appropriately the impact of this nursing work, and it's going to be really difficult to advocate for more nurses to do this job. If you were thinking about, okay, this person speaking is convincing me I really need to advocate and promote antimicrobial stewardship nursing in my country or my region or my facility, I suggest that you have got 3 options, or in fact 4 options to choose in terms of models. Maybe you have got money to appoint a single professional, like a specialist nurse in antimicrobial stewardship, like those ones in the picture, or a nurse consultant in antimicrobial stewardship, which of course is going to give you a lot of visibility, but maybe one person alone cannot have much impact, at least at the clinical level. And of course, the sustainability of that role depends on things like funding, but also that person may decide to leave or may have to leave and move jobs. So this vertical model has got obviously pros and cons. You may, on the other hand, decide to give loads of skills to all the next nursing workforce. So of course, it may be that no one can really see the visibility of the nursing work in AMS because they're doing the day-to-day job. But of course, the impact will be much greater because you will have your whole workforce improving towards antimicrobial stewardship, and they can collaborate with other professions, and that will have, again, its positive and negative aspects. Or you can choose a hybrid model where you can give extra competencies in AMS to your already specialist cadres, like infection prevention and control specialist nurses, and so on. So again, you have to make a decision. But this decision is not just about what people do and the kinds of things that they will do, but you're going to have to think about how are you going to evaluate the impact that these new professionals have in antimicrobial stewardship. And this is a massive challenge. Around the world, there isn't money for more healthcare professionals. Typically, many health systems are struggling in terms of funding, and we haven't really identified what is the unit of output for antimicrobial stewardship nursing. What difference will they make to a patient and to a health system and to the profession? And also, when you are thinking about evaluating these roles, how are you going to measure the support and the improvement that these nurses may achieve in peers and colleagues, the wider profession and other professions? These highly specialist professionals may also have an impact on how well other professionals perform, as we've seen with the impact that pharmacies can have on the prescribing of doctors and other pharmacists around the world. So think about how you're going to evaluate. Coming to the end of the presentation, I'm thinking about education, at least in the European Union, including the UK. Up until now, the nursing degree was composed of 4,600 hours, 2,300 in the classroom and 2,300 in clinical placement. And for many years, when we've tried to improve education, we've only paid attention to what happens in the classroom. But no one up until now had interviewed nurses about what is it that you're learning, if you're learning anything about antimicrobial stewardship in your clinical placement, which is 50% of all your learning in your degree. So this is a paper that we've just submitted about that learning that is taking place during clinical placements, and students in several countries around the world, they're telling us that, it's not very clear the connection between the classroom and the clinical placement. I really want to learn and I really want to do stewardship, but I'm not quite sure about what I'm doing because no one is supporting me. And I'm learning from many different sources, including apps, including what other colleagues, including what other students tell me that I should be learning. So hopefully this will be published soon, but it will allow us to, of course, improve the education about how to do antimicrobial stewardship. And you have got here a beautiful paper from colleagues in South Africa where they took a picture of where the medical and the clinical team was positioned during ward rounds. And, you've got every little symbol there is one professional group. And I dare you to see where the nurse is. That is the nurse away from the patient and away from where decisions making it's taking place. So, of course, now we can do simulation of ward rounds during the training and education of nurses, and we can also train and educate all the other different professionals together so we can make the contribution of nurses much more efficient. Regardless of what you decide to do, regardless of the context, the country, the health system, you have to pay attention to the conditions that are making or not making the contribution of nurses something positive. So, leadership and team culture, you need to look at legislation, you need to look at professional boundaries, and it's a bit pointless to try to implement new roles unless you've got a very clear picture of this context, because otherwise you may spend time and money and energy and hope and aspiration trying to implement these roles and find that they're not successful for no one's fault. It's just that the context wasn't right. And to try to improve and learn about this context is great to see the many conferences and summits and reunions where already nurses and other professionals are talking about this reality and we can learn about it. And it's very important that you try to support the creation of networks of nurses so they can learn from each other as we've done. This is really my last slide. This is your cheat sheet for you to implement nursing roles in antimicrobial stewardship. You've got it all here. And as always, very happy to support and collaborate with colleagues anywhere of any profession to try to improve the contribution. But as probably you've got the sense by now that antimicrobial stewardship is not just what we do with a prescription pad. Antimicrobial stewardship is clearly prevention of infections, and in any context and in any setting around the world, we still can do these three things, which are very powerful in terms of preventing infections, improving infection prevention and control, improving and advocating for vaccinations, particularly pediatric vaccinations, and ensuring access to water and sanitation, not just in health facilities, but of course for our patients and citizens at home and in their communities. And I hope that the last few minutes were useful and interesting, and apologies for the technical problem, but please consider the contribution of nurses, but also please have a look at the organizational, cultural determinants that may make that contribution successful or not. And thank you again for the opportunity to talk to you and the organizers for inviting me. Thank you.
Mute, Captain Madhu.
Thank you, Dr. Hendrik. I'm so sorry I was in mute. Thank you, Dr. Hendrik, for enlightening the session and enriching us with the nurse's role in true sense that how can they make a difference in antimicrobial stewardship program. And that which includes, I loved your sociogram that you have shown where the nurses stand. And it is almost taking the full slide that nurses stand everywhere, right from the time that patient comes in the hospital until the time patient goes home. And then, so I want to ask you one question, is that even after discharge, when the patient is being discharged from the hospital, how do you define nurses' role in ensuring that patients are adhering to the antibiotic protocol, and what is their role in that, and how can they actually they take a part effectively in ensuring part of antibiotic stewardship program?
Thank you ever so much. So I suppose we've got two key pillars, or I see two key pillars. One of them is obviously ensuring education, ensuring that patients make the best possible decision when they are not well, and they need to self-care, and they try not to use antibiotics in a way that is not right. However, the second pillar I see is that nurses, as part of a community, they need to ensure that the citizens, the people in that community, the living conditions are the best possible that they can be, because we know the impact that these determinants of infections will end up having on infections and of course on antimicrobial use. So I don't think that patients wake up every morning thinking that they are going to be using antibiotics in the wrong way. Sometimes they make the best possible decision they can, and housing, accommodation, transport, working conditions, living conditions in general are also very important. And that's something that nurses can try to influence. So educating the community, but also making sure the community, again, doesn't need to use antibiotics and doesn't need to use infections. That will be, I think those two jobs will be very important. They go hand in hand.
Yeah. I think that is very, very crucial for us to think that how can we really expand our horizon in terms of taking roles in terms of not only when patient is there in the hospital, but also the pre-hospital care and the post-hospital care, which is very, very important. I just wanted to request you to highlight something where nursing advocacy and leadership can make a difference in AMS program.
Thank you. That is a crucial step. Any kind of person in any leadership or managerial position needs to consider, I am already paying for this worker. How can I make sure that I make them grow and flourish in antimicrobial stewardship? Do they need education? Do they need guidelines? Do they need mentorship? Do they need support? Do they need feedback and supervision? Do they need praise? As well. So this is an area to improve the service that we offer to our patients and communities. But already these workers are on the salary. So how can we make sure that we support them to be the best they can be? And that to me is a sign of an optimal manager and leader, thinking about how can I make my team the best they can be in this area. And of course, learning from the many successful interventions around the world. I've been fortunate to visit India and see the amazing work that many healthcare workers do, and South Africa and Thailand and Latin America. So I will steal what Dr. Namputiri said before, and without publications, people around the world cannot learn about what's happening around the world unless they can visit, which is not that easy. So those two things will be promote that people publish and promote that they are the best worker they can be.
Great. So let us join hands together to work together towards one goal, and we will be happy enough to be associated with you to do this. Thank you very much for your presence and for giving a valuable suggestions and lot of enriching sessions for us. Thank you so much.
Thank you.
Thank you.
Over
Thank you. So please allow me to give the vote of thanks. So important for me for such a beautiful session. I thank the Apollo leadership, our chairman, Dr. Pratap Reddy, Dr. Preeta Reddy, and Dr. Sangeeta Reddy for their robust support for the National Antimicrobial Stewardship Program. I thank Dr. Madhu Sasidhar and Dr. Rohini Sridhar for their leadership roles for this program and their constant guidance. I thank all the speakers, all the moderators, all the panelists for the excellent, enriching sessions. Thank you, each one of you. I thank Dr. Chinu, Dr. Vikrant, Dr. Rahul Verma for their active support for organizing the webinar. I thank the IT support without which this was impossible. I thank Mr. Manjit Thakur, Mr. Charan Reddy, Mr. Mujahid, Mr. Sujit, Mr. Virendra. I thank the creative team, Ms. Vartika Singh, as well as Mr. Hariharan for the communications. I thank Dr. Nitasha for the communications to the speakers. And I thank all the wonderful audience. Happy World AMR Awareness Week. Thank you.
Thank you.
Thank you so much.
Thank you.
Thank you. We end this meeting.